Hey folks, I wanted to talk about security today as part of application development. As one of my favourite questions to ask during an interview with a full stack engineer is about broad security understanding, and I don't often get great answers. Security for me is for everyone. It's everyone's responsibility. Whilst your company might have a dedicated security team, the people who are best placed to secure an application are the people who are working on it day by day. In this series of videos, I'll dig a little deeper into security as a whole and what we can do as engineers and leaders to help improve security as a whole in our applications. My background is as a software engineer, and I'm currently leading and helping teams improve and architect secure systems in the cloud. But first, what am I even talking about? What are the foundations of information security? One of the key concepts is the CIA triad. Confidentiality, integrity, availability. Confidentiality is making sure information is only available to authorized users, or, to put it another way, it's not available to unauthorized users. Integrity is ensuring that information is accurate and complete and cannot be modified by unauthorized users. Availability is ensuring the information can be accessed when it is needed. Unauthorized users should not be permitted to prevent users from accessing information. The CIA triad is a useful way of thinking about information security. However, it doesn't cover all of the different ways that we might want to secure a system. For example, an unauthorized user could misuse a piece of your hardware. Whilst this would be a security issue, it doesn't necessarily fit perfectly under the CIA triad model. Information security in systems is all about identifying vulnerabilities and threats to an environment and deciding what, if any, countermeasures to enact in order to mitigate that risk to an acceptable level. Security is about balancing risk and access to information. Putting an application on the internet is inherently risky. However, sometimes it is necessary for our customers to have access to information. So it's about having a look at what countermeasures we can put in place in order for our applications to be as risk-free as possible. Nothing is ever truly secure. I suppose you could lock a computer buried in a vault, in a bunker, behind several hundred bank-style doors. However, with enough time and effort, an attacker could still gain access to that computer. Time to get my tinfoil hat out? So one concept we employ is defense in depth. This is multiple layers of security controls used in conjunction with each other to increase the difficulty of an exploit. Time for an example, and by no means is this an exhaustive one. We'll go into more detail later. We may want to lock our servers in a secure data center with biometrics, CCTV, and lots of physical security like locks. As many of us are now using cloud providers for our hosting, these are some of the tactics that they employ. We just simply don't know where those data centers are in the world. We know a rough location. Next, we can ensure our security is up to spec. Adding firewalls to our system, only allowing connectivity between systems that is absolutely necessary, and especially noteworthy is removing all inbound access from the internet. API gateways are great tools for this and can be a proxy and translation layer from any internet-based connections. We also look at encrypting all of our traffic in transit, which can make it harder for eavesdroppers to listen to our information over the wire. Using a VPN or Beyond Corp Zero Trust style solution to access internal systems is also an excellent way of adding an extra layer of defense, which only allows privileged users to access specific networks. This also helps keep those networks off the internet. Then we can look at infrastructure security, the machines that our code or applications run on. We can ensure that they're up to date and that we're running a minimum amount of security in order for our applications to run. We can also encrypt our disks at rest, which makes it harder for unauthorized users to access our data. Servers should also be regularly scanned for vulnerabilities and rectified quickly. This means no more running 2-year-old versions of your favorite Linux distro. Sorry. Now we're down to the application layer. Again, we're going to want to check our third-party dependencies for any vulnerabilities, as a recent report released suggested that 86% of NPM and 74% of indirect Java dependencies contained a vulnerability, with cross-site scripting being the most common. Then we're going to want to review our authentication and authorization layers to ensure they're robust and our role-based access control is working as intended. We can also check that our secrets are not stored in code and are appropriately managed in a centralized secret management tool. So that was a very quick whistle-stop tour of an introduction to information security. If you'd like to see more like this, let me know on Twitter. Thanks for watching.